So we have y is equals to log sine squared x. So then find the y dx. So first, you know that we are going to apply what? Chain rule, right? Function of the function. So first you say let u be equals to the argument of the logarithm, and that's what? Sine squared x. So if u is equal to sine squared x, implies that y will be equals to what? Log u, right? So then from here now, remember chain rule, the y dx will be equals to the y du times the u dx. The y du times the u dx. So first you find the y du. So from here now, this is our y. The y du will be equals to what? 1 over u, right? And from here, we have u to be equals to sine square x. So first thing you have to know about that u equals to sine square x. So remember that this is the same thing as sine x raised to power what? 2. So now you differentiate this with chain rule, function of a function. So if you've watched my previous tutorial, if you haven't watched that, there's a class where I taught a shortcut that you can use to differentiate function of another function. So check through my channel. So one of the videos there, I think it's one of the things that we learned last week. So check it, you get it there. So here now we have sine x raised to power 2. You're going to differentiate this like polynomial. You know polynomial, when you have x squared, that will be equals to 2 into bracket x raised to power 2 minus 1, right? When you have x minus 1 squared, that will be equals to 2 into bracket x minus 1 raised to power 2 minus 1 multiplied by, you differentiate what's inside. So in this case now we have sine x, everything what? Squared. Derivative of this, du dx, will be equals to, you bring these two here, sine x raised to power 2 minus 1 multiplied by, now you redifferentiate what we have in the function. Derivative of sine x is equal to what? Cos x. So from what you have there, du dx will be equals to 2 sine x. So sine x is now equals to 2 minus 1. That's 1. Cos x. 2 sine x cos x. Remember, in trig functions, we have something we call double angle formula. Double angle formula says that cos 2 theta is equals to 2 sine theta cos theta. So from here now, double angle formula, we have that cos 2 theta is equals to 2 sine theta cos theta. So we call it double angle formula. So remember, even I think this is elementary mathematics. It's not for people that learned mathematics actually, so but it's elementary. People that learned further math in their secondary school, they should know this, or at least in your 100 level, you should learn double angle formula. So cos 2 theta is equals to 2 sine theta cos theta. So then from what we have here now, 2 sine theta cos theta equals cos theta. So that implies 2 sine x cos x will be equals to what? Cos 2x. So from here now, it implies the y dx equals to what? Cos 2x. It's the u dx. The u dx. Oh, is it the y dx? The u dx equals to sine x cos x. The u dx is equals to cos 2x. So actually, you can decide to leave it as 2 sine x cos x. That implies the y dx, which will be equals to the y du times the u dx. The y du is equals to what? 1 over u. Backward this video and check that. Times the u dx, which is equals to what? Cos 2x. So that means that will be equals to what? Cos 2x all over u. Cos 2x all over u. I'm thinking about something now. I think I've oversolved this. I've oversolved this. The y dx will be equals to cos 2x. So our u, backward this video and check, you see that we represent u with sine square x. Sine square x. So I think I've oversolved this y. I'm saying something that will be useful here. Right here now. So that means we have to convert this 2x cos 2x back to cos 2 theta sine theta. This is it. You can decide to leave it like this, or bring back our 2 sine x cos x, which is cos 2 theta, all over sine squared x, right? From here now, sine x cancel sine x. So then we have 2 cos x over sine x. Cos x over sine x, that's what? Cot x. So that means we have 2 cot x. So that means the y dx. So implies that the y dx implies that the y dx will be equals to 2 cot x. 2 cot x. 2 cot x. That's the y dx. So this is what we're going to solve in this class. So in the next class, we are going to continue with logarithmic function, where we'll have some other product rule and inside logarithmic functions and quotient rule. So I'll see you in the next class. If you haven't subscribed, don't forget to subscribe. I drop math tutorial every day, 5 p.m. West African time. So I'll see you in the next class.